In this video, we are going to start multiplying and dividing rational expressions. So when we simplify rational expressions, we need to find factors of the numerators and the denominators and then reduce any common factors. They're going to cancel each other out. An expression needs to be factored before it can be reduced. This is always true. When you start learning how to simplify fractions back like 2/4 equals 1/2, you didn't write out the factors of 2 as 1 times 2, but that is what is happening. So first, we're going to go back to our exponent chapter a little bit. It says multiply these two things. These are just a bunch of different factors, right? This is 6 times x squared times y cubed. Multiplication indicates factors. So what we did in that chapter was we kind of grouped things together based on what was on the top, stayed on the top. But I put the numbers together, the x's together, the y's together. I could do that because the order of multiplication does not matter. On the bottom, same thing, 2 times 18 times x squared times y squared times y squared. Didn't really change anything. Now, I'm going to rewrite some of these. This is something that people don't always pay attention to when they do it, and then they get to a different situation and they're confused of what has to happen. I can rewrite 10 as 2 times 5. I can rewrite 18 as 3 times 6. Okay, I could have rewritten 6 as 2 times 3 also. That's fine too. But I'm going to kind of do this along the way where necessary. What I mean by where it's necessary, I'm trying to break things down so I have a matching factor in the bottom. So this 2 and this 2 cancel each other out because 2 divided by 2 is 1. I took something times 1, doesn't change. Similarly, this 6 and 6 cancel each other out. 6 divided by 6 is 1. That's still true for variables. X squared times x squared cancels each other out. Y squared times y squared cancels each other out. Y squared times y, or divided by y squared, I should have said. They cancel each other out. So what I'm left with on the top is 5 x cubed y cubed, and on the bottom there's a 3. There's no more common factors, and I'm fully simplified. What some of us liked to do in this chapter previously, which is still completely valid, they combined this x squared and x cubed to be x to the 5th. Then x to the 5th divided by x squared is going to be x cubed, and it just kind of added more work to the process instead of canceling factors out. In that chapter, the amount of work really didn't change too much, but now in this chapter, if you go that route, you can still get the right answer, but it's going to be a lot more painful. So number 26 here says to simplify. What that means is right away, factor anything and everything that you can. On the top, x times x gives me x squared. To get to a minus 6, I need one positive and one negative. So this is going to be a minus 6 and a positive 1. Because then when I do my outside, that's a positive x. Inside is a negative 6x. Together that gives me the negative 5x. Something to consider when you get stuck in any one of these things is if you can factor something in the top or something in the bottom, it gives you a hint of what to do on the other one. So here I have an x plus 1. On the bottom, there's x squared minus 1. I'm hoping that x plus 1 makes sense as a factor. In this case, it does, because x squared minus 1 is a difference of perfect squares. So now this x plus 1 and that x plus 1 are both factors. They cancel, one on top, one on bottom, because they divide to be 1, just like they did in the previous example. And I get a final answer of x minus 6 over x minus 1. That is my final answer. One thing that people are going to want to do and you can never ever do when you have these sorts of expressions, you cannot cancel these x's. You have to cancel factors. Factors require a multiplication problem. If you are adding a number to another number, you can't get rid of that one piece. You can get rid of an entire expression, x plus 1, because we are multiplying it by another expression. You can't get rid of part of an expression. Have a great day, everybody.